Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 14 in our incredible new tutorial series where you're going to learn artificial intelligence or you're going to die trying. What I'm going to need you to do is pour yourself a nice tall glass of iced coffee. That is straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to track an object, an OII, object of interest. I'm going to teach you to track an OOI, an object of interest based on color. Now you say, wait a minute, we did that last week. No, really what we did last week was we just created the mask and then we applied the mask to the original image and basically we blacked out everything except the object of interest. What we're going to go to today is we're actually on that mask going to find the object of interest and know where it is in terms of kind of like an X value and a Y value of where the object of interest is. So we're not just visually seeing it moving around, but we train OpenCV for a particular object, and then OpenCV knows where in the frame that object is. Okay, so that is what we are going to do today. And what that is called is the command that does that is contours. Basically, you look at that mask and you create a contour around your object of interest. Now, you know, one of the things that I'm always emphasizing on this channel is get it figured out on paper before you try to do it in code. And that's what I'm going to do today, because if I just jump in and start programming, you're not going to understand the data structure for the contour, and you're just going to be copying me, but you're not going to really be understanding it. If I take a few minutes and I draw it for you, then you'll understand that data structure, and it'll make a whole lot more sense when I go in and start coding. So what I'm going to do is I'm going to switch over to our most excellent sketchbook view, and what I'm going to do is I'm going to come up here, and then what we are going to do is draw a frame. Now you could imagine that is that frame that you are grabbing from the camera, and then what we are going to do is we are going to, let's say that we trained it on red, and over here, let me go backwards, let me turn that off. Okay, so what we do is, let's say that we have a red object and we've trained it on red, and just for fun, over here I'll put a smaller red object. Okay, so now we've got two objects of interest. And let's say that we do all the things that we had done before, create the the ranges, and after creating the ranges, create the mask. Now we've got a mask where anywhere that there's red, we have a white dot against a black background. Okay, that's what we did in the earlier lessons. Well, with this command cv2.findContours, it returns to you a set of XY values that define the perimeter of your object of interest. And so you could look at it this way. It would give you a point here, 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 all the way around like this. And then it would give you tuples of the position, x1, comma, y1, x2, comma, y2, x3, comma, y3, and so forth and so on. And so what the find contours will return a contour, and that contour is an array, and it is the point x1, comma, y1, comma, x2, comma, y2, comma, x3, comma, y3, dot, 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 and then you close that contour. Okay, you close that contour, so it's an array of XY coordinates is a contour. But the command find contours doesn't just find one contour, it finds all the contours. So it would also find this one, which would be a different set of XY points. So again, a different X1, Y1, a different X2, Y2, and a different X3, Y3. And so that would then be your second contour, X1, Y1, X2, Y2, X3, Y3, ... And this is your second contour. All right. Now, if it's going to return more than one contour, it has to create a data structure. And that data structure is it puts them in an array. And I'm going to change the color. I'm going to change the color here. And so you have an array of contours. You start the array of contours here, and then you have to close it here, and there has to be a comma between it. And so contours commands returns an array of arrays of XY points, an array of contours of XY points. So it's sort of like a data structure that is 3 deep. So you could kind of think of it as it returns the first contour, comma, it returns the second contour, comma, it returns the third contour, and then it ends the array of contours. And then each one of these is like X1, Y1 tuple, X2, Y2, and so forth. So I hope that makes sense. But the reason this is really important is, let's say that I have something bright like this. Okay, if I have something bright like this and there's only one contour, and let's say it returns that one contour as X1, Y1, X2, Y2, X3, Y3, ... It's not going to return this. It's going to return an array of contours, which means even when there's only one, it is still going to put the outside brackets. It will return an array of arrays, even if the number of arrays inside is 1. I hope that makes sense. I hope that makes sense. Because in some of the commands, if you just put in a contour and it's expecting contours, the program would crash. If you just have one contour, you just end up with one. You have to put the bracket around it so that the data structure here will match. And you didn't see that, did you? Okay, so that the data structures will match. All right, enough of this chit chat. Let's jump in. And what I'm going to need you to do is fire up your most excellent Visual Studio Code. And then we're going to jump in and I'm going to show you how to code this. I'm sorry, got a little bit of a scratchy voice. This is actually the 4th time I've tried to make this video. I've had some bad luck today, and so I've been sitting here talking for the last 4 hours trying to make this video, but I have a feeling that 4th time here is going to be a charm, but I've just got a little bit of a dry throat after all this talking today. Okay, you are going to fire up your most excellent Visual Studio Code, and then we're going to come down, and I do believe that this is going to be program OpenCV -19.py, and the .py is kind of important. Now, we don't want to write this whole thing from scratch because last week the program that we ended up with does all the masking and training and the track bars and all that, so we want to take advantage of that, the work we've already done. If you have that, great. If you don't, you can go to the most excellent www.toptechboy.com, and you want to come over here to this happy little search bar, and you want to search on tracking two colors in OpenCV. It'll bring you to this lesson. This is the code that we ended up with last week. You click on the two little, this is really going to do that to me. Let's see if I reload it. Sometimes that little button doesn't work. And it breaks at the worst possible time. All right, let's see if I can just, nope. Give me a second. I promise you we'll get this thing figured out. Man, this is being quite ornery today, isn't it? There it is. So now we're going to right mouse click copy. We will come back over here and we will right mouse click paste. And then, of course, we always wonder, can we copy and paste without breaking something? So we're going to go ahead and run this just to make sure that we ended up at we're at the same place we ended up with last week. You can see the mask down below, and then over here down below, you can see the composited image. And look at that, boom. It looks like things are working as we left them last week. So we will quit out of this. But now, instead of just showing the object, we want to outline it. We want to trace around it and actually track it. Okay, so in order to do that, what we are going to need to do is we're going to need to find that perimeter. We're going to need to be able to find that perimeter, find that contour that defines the perimeter of the object that we are looking at. And since we want to trace around it, we need to do it on every single frame, which means we need to do it inside of the while loop. We need to do it inside of the while loop. And we need, this is very important, we need to find the contour not on the original image, not on the frame, on the mask that we created. We want to find the contour on the mask that we created. And so we need to find the contour after we find the mask. And remember, in this particular example, we're tracking on two different ranges of hue, and that way we can sort of straddle that red that goes, you know, like above 0 and between 175 and 179, that red range. We want to be able to track that. We need to do two different hue ranges, and this software does two different hue ranges. And then my mask is the composite of the original mask and the second mask, and so my mask is able to basically have both colors in the range. If you watched last week's lesson, that will make perfect sense. So now I have my mask. Now what do I need to do? I need to find the contour. So I am going to say that contours. Why do I say contours? Well, I could have called it my cat boxes if I wanted to, but I'm going to call it my contours, and plural because why? Because that cv2.findContours returns an array, plural of contours. It also returns a second variable, which we don't use, so I just call it junk, but we have to catch it. If it's throwing it at us, we got to catch it. So I catch both parameters, both data structures that this command is going to return. So this is going to be equal to cv2.findContours, cv2.findContours. Well, where do we want to look for the contour? We want to look for the contour not on the frame, but on the mask, okay? And so what this does is, the mask is a white spot, which is our object of interest, against a black background. And so what the command find contours is looking for, it's looking for white spots on a mask. So I want to look at my mask. All right. And now I got to deal with the data. I got to kind of tell it how to structure the data as it comes in, because you could imagine that you might have a red object And inside the red object is a blue object, and inside the blue object is a red object. In that case, I've got to contour a red object inside of a red object. And so how do you want to deal with those complicated data structures? Well, you want to deal with them with the command retr, as in retrieve. Like, how do you actually want to retrieve this data? And you could do like a composite, you could do a flood fill, you could just list them all, or you could have a tree structure. There's all these data structures, but all I want is the outside one. If there's one inside of another, I don't want to deal with it. Just give me the outside, give me the perimeter of the outside one. So what I'm going to say is give me external, like that. Okay. So give me the external one, and that gives me the simplest data structure possible, which makes it easier for me to deal with. Okay. Now I also want to tell it cv2.chain, and that's kind of like, what are we going to do with all of this data, cv2.chain, and then what I want to do is, I don't want every single pixel all the way around. That's too much data. I want it to just give me kind of an approximation with fewer pixels. So I'm going to say chain approx, and then simple, like that. Chain approx simple. Let's make sure you can see that. You can't quite see that, can you? Okay, like that. Chain approx simple, like that. Does that make sense? Okay, so my mask is where I look for the contour. When I return the contours, I only want the outside ones. I don't want ones that are inside of other ones. And then don't give me every single data point. Just give me a nice outline, a nice simple outline. So at this point, I should have my contours if I'm thinking about this right. Well, if I have them, what do I want to do? Well, I want to draw them. I don't want to draw them on the mask. I want to draw them back on our original frame. And that way I can outline my object of interest with a drawn in curve around it. How would I do that? I would say cv2.draw contours. I want to draw the contours. Where do I want to draw it? Well, I got the contours from my mask, but I don't want to draw them there. I want to draw them back on frame, my original image. I want to draw them on the original image. Okay, what do I want to draw? Contours, right? Why do I have to tell it that? Well, I might have given it lots of different contour commands, and I might have lots of different arrays of contours. I've got to tell it which one. Well, the one I just found, which I called contours. If I called it my cat boxes, I would put my cat boxes in here. Okay, now I need to tell it that's an array of contours. Which one in the array do you want to draw? I don't know. Draw them all. How would I say draw them all? -1. Okay. Now, if you said a 0 here, it would draw the first one. If you said a 1 here, it would draw the second one. But you see, the first one might just be a little random pixel over here, a little bit of digital noise. I don't know if the most important one is first, so I'm just gonna for right now draw them all, and then we'll sort it out later. Okay. And then what color do you want it? You put color as a tuple. Let's put it blue. That would be 250. Remember, it's blue, green, red. So 255 full on for the blue, off for the BG, off for the green, and off for the red. Okay. Now, how thick do you want that? How heavy do you want that contour? I'll make it a 3, which is pretty heavy. Okay. If I'm thinking right, guys, this should trace out my contour. Let's see. Good news is the program didn't crash, and then boom, look at that. Okay, do you see how I have traced out my object of interest? What do we like? We like that I have traced out my object of interest. What do we not like? We don't like that the noise down in the mask, each one of those little pixels is showing up as its own contour. So if you look at my hand, it's putting all those dots on my hand because each one is like an individual contour. We got like way too many contours. Now, there's several ways that you could handle this. One way is you could sort your arrays of contour in the order of what their area is, and then only print the first one, only draw the first one, the biggest one. Okay, another way you could try to do it is just try to tune your way out of the problem. Okay, I'm going to try to tune my way out of the problem by adjusting these track bars. Okay, and in this case, I was able to tune my way out of the problem. But in this case, I've got a bright yellow object of interest against a bright green background, and I am wearing a lavender shirt. And so it's pretty easy to tune in on yellow. In most real-world applications, you're not going to have things that easy, so you cannot solve it simply by tuning it carefully. And so we've got to get a little bit more clever. And what we want to do is we only want to trace the contour if it's a certain size. And if it's smaller than that, we're just going to assume it's noise and we're not going to trace that one. Okay, so if we're going to do that, how would we go about doing it? Well, I want to start by commenting out this because we're going to do it in a more elegant way now. And what we are going to do is we're going to step through the contours. So I'm going to say for contour single in contours. So with this for loop, the first time through contour is going to be the first contour in contours. The next time through is going to be the second contour in contours. It's going to step through the contours. All right. And then what I want to do is I want to find the area. I want to find the area of the contour. So I'm going to say the area is equal to CV2 dot contour area. Now, what do I want to find the area of this contour? This command is not expecting the full array. It's expecting the contour you're interested in. So just one. So I'm passing it what? Singular, just one, the contour. Now I've got the area of that contour. If the area is greater than or equal to, let's say, 100 pixels, then it's a keeper. It's a real one. Okay, if it's a real one, what will I want to do? I will want to CV2.draw contours. I want to draw them on what? On frame. I want to draw what? Contour. I want to draw that contour. Okay, and then this time, I don't want to do them all, right? I just want to do one, the first one, which is the what? The 0th one. Okay, I want to do the 0th one. All right, now what color? Let's keep it blue. Let's go 255,0,0 inside that tuple. And now how heavy do I want the line? I still want the trace to be a heaviness of 3. Now this is where you have to pay attention. This draw contours command, it is expecting what? It is expecting what? The array of contours. And I am passing it a single contour. There is a shape mismatch in the data because it wants an array of arrays and I'm just giving it an array. Well, the easiest way to do that, I could just come here and say my contour is equal to, and then I'll put contour inside of those outside arrays. And so I've just put the array in an array, and there's one array in the array, but yet still it's in there. So I could do it that way, and then I would put here my contour. Now that would work, but there's a little bit of a shortcut you can do, and that is I can put that contour in an array by just putting the array brackets around it. And now I am passing draw contours an array of contours. How many contours are there? There's one, okay? And therefore the first element is the 0 element, and this should work. So let's take a look at this, unless of course the silly old typos. Good news is it didn't crash. Boom, look at that. Okay, now what I'm going to want to do is I'm going to want to deliberately come in here and kind of detune this. You can already see there's all that noise around my hand, but it did not draw it. And let's see if I can get a little more noise there. Okay, that it's getting big enough that it's drawing. But okay, do you see in the mask there is all that noise, but in the image up here there is not anything except for the object of interest. Okay, now you see sometimes it is drawing something that shouldn't be there, and so the way I could deal with that is I could come up here and say, well, let's only draw it if it is 200. Okay, so I can kind of get rid of that noise that way. Okay, so in the picture down there, you still see the noise, but here you don't see the noise. You only see the object of interest. Pretty darn cool, huh? All right, but you see, I really don't like tracing around it. I want a bounding box around it. So instead of drawing an outline around it of the perimeter, I want to create a bounding box. And so if I am going to create a bounding box, I'm going to come back over here. I should get rid of this. Yeah, that will give you more things to see here that are useful. All right, so I'm going to comment this out, and then I'm going to come down here, and what am I going to do? I'm going to find the box that contains the contour, and I do that by using the command CV2, and I've got to put this equal to something, but I'll just show you the command. It's CV2 dot bounding rectangle, like that. I want to find the bounding rectangle of what? Contour singular. And you got to keep track. Bounding rectangle wants one contour. Okay. That other one, which was what? That other one, the draw contours, it wants the whole array of contours. So you got to keep track. What wants a single contour versus what wants the whole package of contours. Well, bounding rectangle, you just pass it a contour, and then it will return to you. It will return to you the information you need to draw a box around it. And so what does it return? It returns 4 numbers, the X coordinate and the Y coordinate of the upper left corner of the bounding rectangle, and then the width of the bounding rectangle and the height of the bounding rectangle. So if it is sending us 4 parameters, we have to catch what? 4 parameters. So I'm going to catch it in X, in Y, and then comes width, and then comes height. Okay, so now I've got a variable for each one of those parameters that it's going to throw back to me. Okay, so now I know what I need to draw a box around my contour. And how would I do that with our old friend CV2 rectangle? You should already know this. And I want to put it on what? I want to put it on the frame because that's what I am working on. And then I've got to tell it in a tuple the coordinate of the upper left corner. Well, that I already have. It is X comma Y. Make sure that you're putting it inside those parentheses as a tuple. And then I need the bottom right, the upper left and the bottom right. Well, what would the bottom right corner be? Well, it would be X plus the width and then Y plus the height, like that. And now that should box up that object of interest. And then I commented out my draw contour, so this one should just be a box, but I need a little bit more information here because in fact it is going to want a color. Let's make it a red. So it's blue, green, red, and it's in a tuple. So the first one blue is 0, the second one green is 0, and the third one red is full strength 255, like that. Okay, I think this is going to run. Okay, good news is it didn't crash. Now let's look. Boom! Look at that, huh? Object of interest tracking with a box. What I don't like there is I did not give it a, I didn't give it a heaviness, and I want a bigger box, so I should have put comma 3. I think it used the default of 1, and so this should be a bigger or a heavier box. There you go. Look at that. You see, I am tracking that object. Shazam. Okay, That is pretty cool. Okay, so you see, I think that is really neat. And so now we can actually kind of formally track an object, and we're tracking it based on color, and we train that color using trackbar. So this is really starting to kind of look like artificial intelligence, right? Because we train it on a color, and then we track an object based on the color. Then there's all types of interesting and useful things that you can do. So real quick, there's 3 things I need to do. I need to give you the homework assignment for next week. I need to give you the solution to last week's Person of Mystery contest, and then I need to give you a new Person of Mystery contest for next week. Okay, so let's see if we can get through this. What I want you to do for next week is I actually want you to do something with the data that you're getting from the tracking, right? It's just, don't just draw it, actually interact with your computer. You can use this to actually input to your computer. Your computer can get input based on what it sees happening in the real world. And so what I will do is, rather than try to tell you in words, what I will do is I will run the program, and then you can see exactly what I want you to do. So give me just a second here. I believe that will do it. Okay, so you see me, you see a mask down below me, right? Okay, let's see if I can do this. Here we go. Okay, I need to tune it a little better. Let me tune it a little better. Okay, that looks good. Okay, so now the object of interest is in the center of the frame, and the frame is in the center of my screen. As I move it this way, the frame moves that way. As I move it this way, the frame moves this way. Let's see here. Let me make sure that you guys can see that. Okay. Yeah, you can see that. Okay. So I can put it up in this corner. I can put it down in this corner. I can put it up. The funny thing is, it's mirror image from what I'm looking at. So everything's going the backwards direction. Okay. But you see, if I put it in the center, it's in the center of the screen, and wherever I move it, it puts the frame in that area. I think that is just pretty darn neat. I think that is just pretty darn neat, because you're actually now, your computer is doing something based on what your program sees. You could use this to like adjust the volume, or you could adjust the color balance, or you could do different things that if you combined it with like mouse clicks or other things, you could sort of start developing a gesture-based input system for your computer that could do all types of different things. And so I just did this assignment just so that you could kind of get the concept of, I can get data from the screen, and then my program or my computer can do things based on that data. Okay, I am making this video before I have released the video that had the Person of Mystery contest. So I don't know if any of you guys got this or not, but the Person of Mystery last week was, who was this? And this is in fact William Shockley, and he is quite famous because he invented the transistor. He was like one of 3 people, but really, he was the one, he was the primary person behind inventing it. And remember, the whole idea behind a digital computer is everything is zeros and ones, and all math can be put in terms of zeros and ones. And so whether you're talking about data or calculation, everything is zeros and ones. And the way you could make a computer is, all you need is a switch. And if the switch is on, you count it as a 1. If the switch is off, you count it as a 0. So if you want to make a computer, you just have to have a whole bunch of switches. Well, back in the day, they made those switches with vacuum tubes, and vacuum tubes were very big. They were very expensive. They used a huge amount of power, and they broke down all the time. They would burn out all the time. Those things use so much power. One of those vacuum tubes, you could actually bring a piece of bread in, and you could make toast over that vacuum tube. Vacuum tube would be about this big. So computers didn't have much computation power because you couldn't have very many switches, used a whole lot of power, and broke down all the time. Well, what Mr. Shockley, Dr. Shockley figured out was he came up with a way to make a switch in silicon, And it was very small, it was very low cost, it was very low power, and it would basically run forever without breaking down. And with that, then you could make the transistor smaller and smaller and smaller. You could pack a bazillion of them onto a chip, and that is sort of what enabled the computer revolution. Sort of the silicon revolution was enabled when it was determined by Mr. Shockley that you could build a transistor, a switch out of silicon. So he is probably kind of like of all the people that have lived on, all the living people, inventors, he probably has more profoundly impacted the world than just about anyone else. And so that is the little story of the transistor. That is Shockley. Okay, so now we're going to go to the person of mystery for next week, who is going to be this guy. Who is he and why is he important? Okay, so guys, I hope you're having as much fun taking these lessons as I am making them. Also, on the homework, I love it when you do the homework and then you do a screen capture and upload it to YouTube, and then down in my comments below, provide a link over to your homework solution. I go over there and I watch your solutions. I really enjoy watching your solutions. Then when you upload it to YouTube, make sure in the description to put a link back to this video so anybody that watches it will have context as to what you're trying to do. Okay, guys, if you like this video, give us a thumbs up. Be sure to tune in later this week for the solution to this homework assignment. If you have not already, subscribed to the channel. And I'm really having a lot of fun with this. Hope you guys are enjoying it too. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.